So first principles part 2, we're still, notice here, we're still finding the value of the derivative at a point. So we're still going to use that original formula that we had, which was, but notice here that we're using different notation. So instead of using f of x and then f dash of x, so f of x and f dash of x, we can use y and dy on dx. dy on dx just means the derivative of y with respect to x, and that's what you're doing. You're differentiating y, finding the derivative of that in terms of x. Okay, so we still use the same formula pretty much, but we can just use a slightly different notation. So the derivative of y with respect to x is going to equal the same thing as, I'm going to treat this for now as if it's a question where we've got f of x equals square root of x, 3x take 2, and we're going to find f dash of x. Alright, so I'm just going to put f dash of x, but instead of x I'm going to put 2. It's going to equal the square root of 3x take 2, take the square root of 3 times 2 take 2, all over x take 2. Now again, make sure that you always put, don't leave it out, the limit as x approaches 2 of that. Alright, it's going to equal the limit as x approaches 2 of that thing. So that's going to equal the limit as x approaches 2 of the square root of 3x take 2, take the square root of 6 take 2, which is 4, over x take 2. So that equals the limit as x approaches 2 of the square root of 3x take 2, take, now the square root of 4 is 2, so take 2 over x take 2. Now we've got this interesting thing up the top. It's called a surd. It's got an irrational point in it. And so we want to get rid of that square root of 3x take 2. What we're going to do is set up difference between two squares. Difference between. So we know that a plus b times a take b equals a squared take b squared. So what we're going to set up is a very similar thing. We're going to set up the square root of 3x take 2 plus 2 over the square root of 3x take 2 plus 2. Again, we're just multiplying by 1, very similar to the above one. So that's the limit as x approaches 2 of, well, we've got a, that's the square root of 3x take 2, so it's going to be that squared. Square a square root, you just get left with the same. Take, and then it's going to be take 2 squared, so that's going to be take 4. Alright, all over x take 2. Now it's looking a bit more human. That's actually remembering that on the bottom, of course, remembering on the bottom, you've always got to keep on this thing, but you don't expand it. And because the whole bottom thing is multiplied by that, that goes in brackets. X take 2 must go in brackets. So we get the limit as x approaches 2 of 3x take 6 over bracket x take 2, bracket 3x take 2 plus, oh, don't put that under the third. Let's just erase that bit. And it's going to be plus 2 over there, not under the third. And so what we get there is we're going to then factorize the top line. So again, very similar to the last one. So we're going to go limit as x approaches 2 of 3 bracket x take 2 over x take 2 outside of bracket 3x take 2 plus 2. So we cancel those brackets and we get the limit as x approaches 2 of 3 on 3x take 2 plus 2. And then we can just substitute in. You get 3 on 6 take 2, which is 4, plus 2. So that's going to be 3 over 4 as our answer. So again, what did we do there? Let's look at the whole thing. If we look at the whole thing, then we can just write some general rules for how we would solve this. These do look tricky, and they are the trickiest you get, but if you follow the steps, they're not actually that difficult. So what we first do is we just use the formula, but then what we do is we set up difference between two squares. We just did that by multiplying by the plus, same thing but plus. If it had been add, we would have multiplied by the same thing by take, but it will always be take here, so we will always need to add. And then we simplify the top, and then we factorized, and then we cancelled, and then we substituted. Alright, so if you follow those steps, these will all fall out quite nicely. So there are a whole lot of ones where we actually wanted to find the derivative at a specific point. But remember, we talked about this before. It's established that the function has an associated derivative function. Alright, the derivative function that can be found using first principles, which we just talked about. So what we just did was we found the value of the derivative at a specific point. But remember, in the previous video, we talked about if you have a graph, you might not want to just find it at a specific point. You might want to know the generic equation that will always work for this graph, so that all you have to do is sub in the number. So remember, when we talked about that, we said that the equation for that was the limit as h approaches 0 of f of x plus h take f of h over h. So h in this case gets smaller and smaller, and we talked about why that was the case before. So if we're finding for using first principles, just the derivative, not the derivative at a point, just in general the derivative, what we do is we use that formula. So we go f dash of x is going to be the limit as h approaches 0 of f of x plus h take f of x over h. Alright, that's a general formula. So now let's put in that. So what this means, remember, f of x plus h, the thing in brackets, you replace the x in your function by the thing in brackets. So we're going to put limit as h approaches 0 of, let's replace the thing in brackets with the actual function of x plus h all squared. Okay, so I've taken this and I've put it in there. Okay, then we're just going to take the actual function, so that's going to be take x squared, and that's going to be over h. Now in these cases, we want to get rid of the h off the bottom, so we're going to have to do some factorizing. First, we're going to expand the top line, and we're going to get x squared plus 2xh plus h squared take x squared. Now if you're wondering how I did that, remember that you've got x plus h squared is a perfect squared, and that will always factorize to be something like this. Alright, now we know x squared and take x squared cancel out, and so we're happy because that means we can factorize, and we get h outside of 2x plus h all over h. We cancel the h's. We just get left with 2x plus h, so we substitute in h for 0 for h, and we get 2x. So that means if we've got this graph, f of x squared, which is a nice easy one to draw, if I pick any point on there, so say I pick that, and the value of the derivative at that point, okay, the value of the derivative at that point is going to be 2 times x. Now x at that point right there is 0, so it's going to be 2 times 0 equals 0. That makes sense because the slope of that function, this tangent, is actually 0. Then it goes on to hence find f dash of 4. Well, that's really easy because all you have to do is substitute in 4. So you get 2 times 4, which equals 8. Over here, f dash of negative 8, you get 2 times negative 8, and that's going to be negative 16. So once you've found the actual function, it's quite simple to go on and do those extra questions. Okie dokie, so for this one, I'm just going to change that to f dash of x, and I'm going to change that y to f of x. So we're going to use the same formula as before. We're going to use the formula For finding the gradient function, so we're finding the slope function or finding the derivative, means the same thing. We're going to use the formula that f dash of x is going to equal the limit as h approaches 0 of f of x plus h, take f of x all over h. So let's substitute in the values we've got here. It's going to be limit as h approaches 0 of 5 over 3 bracket x plus h plus 2, take f of x, which is 5 over 3x plus 2. Okay, now we're going to put that all over h. Now what we did in the previous one where we had a fraction like this was we first wrote the question so that they had the same denominator. So we did 5 bracket 3x plus 2, take 5 outside of 3 bracket x plus h plus 2. So we sort of cross multiplied across here, all over, and then we multiplied the two denominators together, 3 bracket x plus h plus 2 bracket 3 bracket x plus 2. Alright, and that's still all over h. So you'll notice very similar to what we had before. Then what we did was we multiplied by that denominator over that denominator. That lowest denominator, remember we said we'll multiply the LCD over the LCD. That was one of our rules. So that is going to equal the limit as h approaches 0 of 5 bracket 3x plus 2 take 5 bracket 3x plus h plus 2 all over this big denominator times this denominator over that denominator. So we'll get something that looks like that. Again, looks horrible, but remember what we can do is we'll be able to then cancel out these. Okay, because that's on the numerator, so we can just cancel out that. So remember, next step, we never simplify the denominator. I'm going to go into the next section a little bit, or I'll just go over here a bit. We never cancel the denominator, so the next step is going to be simplification of our numerator. So that is going to equal the limit as h approaches 0 then of 15x plus 10 take, now I'm just going to be careful here because I'm going to do the brackets bit first and then simplify it. So the 3x plus 3h plus 2, I'm going to do that first, over h times 3 bracket x plus h plus 2 bracket 3x plus 2. Now this is remembering all the time that what we're trying to do is get rid of the x's so that we can get an h on the top and cancel the h's. That's what you're aiming for. So that's going to be the limit as h approaches 0. Simplify the top more. 15x plus 10, take 15. Now that is 3x, even though it's not very clear. Take 15x, take 15h, take 10. Alright, all over h times the thing. I'm getting lazy, I'm not going to write it, but you need to write it. So that's going to equal the limit as h approaches 0, and then a whole lot of stuff just falls out. That's the beauty of this. If a whole lot of stuff doesn't fall out, you know you've done the wrong thing. So that cancels with that, and that cancels with that, and you get left with negative 15h over h times, alright, let's write this thing in now, x plus h plus 2 times 3x plus 2. And what you get left with is this general equation for your quadratic, and that's perfectly fine to leave it like that. It doesn't say to simplify it. It's good to write over here you're assuming that h is not equal to 0, because that's what you're assuming. That's why you can cancel. So make sure before you cancel you're just saying h is not equal to 0. So you get negative 15 over, if you simplified that whole bottom line down, you would get 3x plus 2 all squared, but you wouldn't have to simplify it like that unless it specifically asked you to do so. So again, it does look horrible, but all we did was we followed the steps that we did in the previous part when we were actually finding it at a specific point. So even though you're using h, and you're using a slightly different formula, it still works in exactly the same way. So likewise with this is going to work in exactly the same way as the example we did before. So if we're doing f dash of x, we're going to go f dash of x equals the limit as h approaches 0. If you want to have a go at doing this first without looking at this, you can. I'm just writing the formula again to see if you get it right. Because it's using the same principles that we talked about right at the start of the video when you've got a surd. So what you're going to do is initially just substitute in everything. So for x, you're going to put x plus h. And so what you're going to get is that f dash of x is going to equal the square root of x plus h plus 1, take the square root of x plus 1 over h. Now remember what we do here is that we form difference of two squares. So we multiplied that by x plus h plus 1 plus x plus 1, because we put the opposite sign in, over the same thing, the square root of x plus h plus 1 plus the square root of x plus 1. What that does is that it forms difference of two squares and we get rid of our surds, which is what we want to do because we surds are hard to work with. And so what you get left with is x plus h plus 1 take, in this case it's just going to be take x plus 1. Now I put it in brackets because it's really important that that negative sign stays in front of the brackets, otherwise it's going to be incorrect. And so your bottom line is just going to be x times h times square root of x plus h plus 1 plus the square root of x plus 1. And now that you've done that, you'll notice that a whole lot of things will cancel out. So if you simplify that one line further, you get x plus h plus 1 take x take 1, and then you get the beautiful denominator. Guess what I'm missing? All my limits as h approaches 0. So we get f dash of x equals h over h times the square root of x plus h plus 1 plus the square root of x plus 1. And so if we cancel the h's, we get left with this beautiful thing underneath. Now you'll notice there's still an h underneath, and you might go, well, that's a problem. Again, we're putting h not equal to 0, but it's not. H in itself on the bottom is not a problem. It's just a problem when it's on its own, because then if you try and substitute in 0, you're going to have a big issue. So what we need to do then is just replace that h by 0, and what we'll get is that when we simplify that, we're going to get that's going to be equal to f dash of x is going to equal the limit still as h. So now we don't put the limit in anymore because we've actually found out what it's equal to, so we're not going to put the limit in anymore. So it's just going to equal 1 over the square root of x plus 1 plus the square root of x plus 1, which is of course the same as 1 over 2 bracket x plus 1. So again, looks a bit scary, but use the same procedure as we talked about before and you'll be absolutely fine. I should have a limit as h approaches 0 up here because I haven't substituted in. You only get rid of that limit when you substitute in. Alright, so I hope that helps.